Clarification has been something else, suggested as the speculation of the old. Endless effect, various examinations, other than those made by a tremendous number of examiners support this thought, giving confirmation about how the universe began anyway. The current universe of science with new movements brings us novel appraisals and points of view. These assessments challenge areas of view where certain bits of information, for example those from Neil deGrasse Tyson, have transformed into a huge addition. This impacting the universe of science. Now something intriguing is going on with the James Webb Space Telescope. It's critical to see something that could make us question the speculation of the universes. Beginning, the James Webb Space Telescope has seen 750 new universes. These frameworks are not exactly what we anticipated, driving us to rethink what we expected. We had some attention to them. This revelation ought to help us with appreciating how gigantic frameworks turned out to be. So it's not astonishing that it's stirring up how we would have the choice to loosen up the universe. Before, specialists said that the Big Bang speculation was an excellent explanation for how the universe began. According to this speculation, around 13.8 billion years ago, the universe appeared through a bewildering event, like the crazy story of the first experience with the world. In any case, the photographs from the James Webb Space Telescope have tried this thought. These photographs show universes that are more unobtrusive, smoother, and more prepared. Without a doubt, they are not exactly the same as what the speculation of how things came to be predicts. According to the hypothesis, as the universe expands, objects should look more discernible the farther away they are by, and by these lofty plans, make an effort not to keep that standard. The speculation also states that at the universe's veritable start, all of the matter that makes up the universe was fit into a second supero called a singularity. This singularity was incredibly hotter than anything that we might genuinely measure or make. This idea of a singularity comes from a great deal of conditions in real science proposed by Albert Einstein called general relativity. Inside the singularity, all the stuff in the universe was squashed into a small space with incredibly high density. It was a monster measure of mass and energy stuffed into a little space. In simpler terms, experts have persistently said that the speculation of how things came to be was the means by which the universe began. In any case, these new pictures from the James Webb Space Telescope are making us question that thought. The universes it found don't fit with what the speculation expected, and the speculation explanation of the early universe likely will not be just about as solid as we once suspected. In our determined viewpoint of the universe, we see that all the energy in the universe began from an extremely hot and thick point called a singularity. This point resembles the beginning phase for all that we view as in the universe today. After this singularity, the universe started to develop and make over generally 13.7 billion years to become what it is today. The expansion began with something various refer to as the incredible inflation, where the universe became limitlessly quickly, essentially faster than the speed of light. Perhaps the veritable surface of space itself was developing, and everything in it was stretching out close by it. This tremendous expansion helped shape the universe by making things more uniform and paving the way for universe's stars and other impact events to form. As the universe kept on creating, it didn't reach out as quickly as during the remarkable inflation. However, it still continued to develop. We call this consistent advancement, cosmic progress. Experts have seen evidence of this increase through things like the way light from distant universes changes in color, known as redshift. Now let's see those astonishing pictures of new universes taken by the James Webb Space Telescope to the larger part these photos look stunning with diverse universes in a singular frame at any rate. For examiners, it's somewhat a shock that these photographs don't match what their hypotheses expected. As an issue of some importance, these universes are surprisingly prepared, which challenges our point of view on framework design and movement as demonstrated by the speculation of the old Big Bang. There are also essentially more egotistical structures than we expected. The speculation of the universe's beginning made assumptions about the quantity of structures there ought to be and the way that they ought to be fanned out. However, the JWST pictures show a gigantic number of universes, some more than anticipated. This makes experts question whether the theory's checks are accurate. A couple of experts are at any rate beginning to overcompensate a bit, thinking about the way these disclosures make an effort not to fit their ideas in any way. One more astonishing piece of the new grandiose plans is their faultlessness, which conflicts with what the speculation of how things came to be proposed, as demonstrated by the speculation universes ought to show anomalies and plans in their designs because of how they outlined and developed. However, photographs from the JWST show universes that are extremely smooth without the normal intricacy and ruthlessness during the development of the universe. All that makes up our universe was condensed into a little space as the universe expanded and cooled. Changes happened in particles like protons, neutrons, and electrons, which began to interact with light and energy around them. These interactions played a huge role in the development of matter in the universe. In the initial few minutes after the Big Bang, there was a process called nucleosynthesis, which involved the creation of lightweight parts like hydrogen and helium. These parts set the stage for the advancement of stars, galaxies, and other complicated components. As relentless history unfolded, this blend of fundamental building blocks was a key stage in the universe's improvement, progressing from a starting state of particles and energy to a state where matter began to form just as predicted. The speculation of the old Big Bang had expected to see universes that were dispersed and tempestuous. However, the JWST pictures tell a different story. Rather than tempestuous, dispersed universes, the photos reveal smooth, round, and spiral shapes resembling the galaxies we find in the present-day universe. This disturbing discovery challenges the belief that disarray is a normal part of universe development if there are few or no violent events occurring in these universes as proposed by the speculation of how things came to be. It becomes nonsensical that small universes would be capable of developing into more significant ones. Similarly, the optical phenomenon expected by the developing universe theory, where objects appear smaller with increasing distance, due to expansion, doesn't seem to be observable in space. Experts have observed a striking model where large plans will frequently assemble in massive groups, forming various associations across the universe. This enormous degree structure lines up with the assumptions made by the speculation of the universe's beginning. According to the speculation, the universe began in an extremely hot and thick state, and then broadened and cooled over time. As the universe expanded, gravity played a massive role in shaping how matter was distributed and in arranging galaxies. The gravitational effects expected by the speculation of the old Big Bang are consistent with what we see today, with gravity organizing matter, causing the gathering of vast galaxies and the formation of interconnected filamentary structures known as the cosmic web. The presence of these galaxy groupings and the self-organizing web structure strongly supports the theory of the old Big Bang, how galaxies are scattered across the universe lines up with the gravitational influences expected from a dense expanding state as proposed by the speculation. These components, including the clustering of galaxies, the self-organizing web structure, and the spreading of galaxy clusters, strongly suggest that the universe came from an extremely dense state and has been developing for billions of years now. We should return to the size of the design observed by the JWST. These photos conflict with what we thought we understood about the Big Bang Theory, as demonstrated by the theory small universes should form and expand through influences and solidifications with other galaxies. However, the galaxies made by the JWST seem very different from this idea, assuming that cosmic formations were interacting and merging. As expected, we would see evidence of these collisions and mergers. However, the photographs show something else. The Big Bang is still a truly remarkable hypothesis, essentially a thought without conclusive proof. Note it is really supported by undeniable evidence, including observations of the redshift of light and insights from distant galaxies, which offer support for the expanding universe theory. Studies showing galaxies growing their distance from one another propose the expected constant expansion predicted by the speculation. The spread of light elements like hydrogen and helium seen throughout the universe is too consistent with the theory of the universe's origin. Additionally, the large-scale distribution of galaxies, as revealed through cosmic maps, matches the models expected by the theory of how things came to be. One of the primary pieces of evidence for the Big Bang Theory is the discovery of the cosmic microwave background CMB. The CMB is weak radiation that fills the entire universe and represents the leftover heat from the Big Bang. This massive radiation, first recognized in 1965, still aligns with the predictions made by the theory of the universes beginning. The above qualities of the CMB, its consistency and temperature distribution, strongly support the idea that the universe was once in a very hot and dense state before undergoing expansion. A central piece of the theory of how things came to be, the discovery of the cosmic microwave background, is a vital piece of evidence that offers us a remarkable look into the early minutes of the universe, helping to examine the extent of the universe's start and development. The James Webb Space Telescope, JWST, has been one of the most anticipated space missions in recent history, touted as the successor to the Hubble Space Telescope, launched on December 25, 2021. JWST is designed to study the cosmos in infrared light by peering deeper into the universe than ever before. JWST hopes to answer crucial questions about the formation of galaxies, stars, and planets, as well as uncover new unseen phenomena. By focusing on infrared light, the JWST can study objects too faint or distant for visible light telescopes to detect. This is particularly important for observing the most ancient galaxies, as light from these objects has been stretched, redshifted by the expanding universe, shifting it into the infrared spectrum. JWST power comes from its large, segmented primary mirror and its position in orbit 1.5 million kilometers from Earth at the second range point L2. This enables the telescope to see the universe in unprecedented detail, providing the sharpest images ever captured in the infrared spectrum. The findings from JWST are helping astronomers push the boundaries of our understanding of the universe as its observations continue to revolutionize cosmology and the study of the origins of galaxies and other cosmic phenomena. The telescope's impact will only grow, revealing answers to the mysteries that have captivated scientists and stargazers alike for centuries. JWST groundbreaking discoveries have already begun to reshape our understanding of the early universe and the formation of galaxies. The images it has captured reveal galaxies that are much older and farther away than previously thought, challenging some of the assumptions made by earlier models of cosmic evolution. In particular, the telescope has provided a closer look at the so-called first galaxies, which formed just a few hundred million years after the Big Bang. These early galaxies are significantly more complex than expected, with more defined structures and mature features, raising important questions about the timeline and mechanisms of galaxy formation. The surprising findings from the JWST have also sparked renewed debates over some of the key assumptions behind the Big Bang theory. For instance, the discovery of early galaxies that appear to have already developed significant amounts of mass and structure contradicts the idea that galaxies took billions of years to form from smaller primordial clumps of matter. Some researchers are now exploring alternative theories or adjustments to the Big Bang model that could explain these observations. One of the most striking discoveries made by the JWST is the apparent presence of supermassive black holes in the centers of some of these distant galaxies. These black holes, which are millions or even billions of times the mass of the Sun, seem to have formed much earlier than expected. The formation of such enormous black holes in the young universe raises fundamental questions about the process of accretion and the growth of black holes over cosmic time. Moreover, the telescope has provided unprecedented insights into the early stages of star formation by observing galaxies at various stages of evolution. The JWST has shed light on how stars and stellar populations develop over time. These observations are helping to refine models of star formation, including the rate at which stars form in different types of galaxies and the processes that govern their evolution. Another fascinating aspect of the JWST findings is its ability to study the atmospheres of exoplanets. The telescope's infrared capabilities enable scientists to detect and analyze the chemical composition of distant exoplanet atmospheres, potentially identifying signs of habitability or even life. The discovery of molecules like water vapor, methane, and carbon dioxide in the atmospheres of exoplanets opens up new avenues for the study of life beyond our solar system. JWST observations could be crucial in answering the age-old question, are we alone in the universe?